Quantum immortality. It's one of those ideas that sounds ridiculous when you first hear it. In essence, it suggests that from your own point of view, you may never be able to experience your own death. In simple terms, if the universe splits into multiple possible outcomes, then there will always be some version of reality in which you survive. And if your consciousness can only ever continue in branches where you're still alive, then subjectively, you would never reach a moment where everything just ends. At first, all of this sounds ridiculous, like pure science fiction, a story about endless parallel worlds, alternate versions of you, and some strange loophole in death itself. But people still take the idea seriously, not because it offers a comforting promise of eternal life, but because it grows out of a real problem at the heart of modern physics. A place where our best theory of realities stops feeling like a clean explanation and starts feeling like an argument against common sense. Quantum immortality is not disturbing because it says you might live forever. It's disturbing because it asks a more corrosive question. If reality never chooses a single outcome, then why do you experience a single life at all? To understand why that question is so unsettling, we have to start with the part of quantum mechanics that physicists have spent nearly a century trying to explain without ever fully resolving. At the quantum level, particles do not behave like tiny solid objects following clean, deterministic paths through space. They're described by something called a wave function, a mathematical structure that encodes multiple possible states at once. In simple terms, a particle can exist in what is known as a superposition, meaning not simply here or there, but in a distribution of possible outcomes that only becomes definite when the particle is observed. And yet, when we look at the world, we don't encounter blurred clouds of possibility. We encounter single events. There's a particle here, the door is there, there's a window over there. It's one reading, one outcome instead of all of them at once. Somewhere between mathematics and the world as it appears, infinite possibilities seem to harden into singular fact. That's the measurement problem. And it's not some minor technical issue hidden in the machinery. It is the point where the most accurate theory in the history of science becomes strangely silent about what reality is actually doing. For decades, the most widely taught response to this problem was the Copenhagen interpretation. In its broadest form, it says that the wave function evolves as a spread of possibilities until an observation or measurement takes place, at which point it collapses into one actual state. Before observation, multiple outcomes remain alive within the formalism. After observation, only one remains real to us. This story is neat, it's teachable, and most importantly, it appears to match experience. But inside that apparent simplicity is a deep and unresolved instability. The mathematics themselves do not clearly specify what counts as a measurement. It doesn't tell us exactly where the line sits between the quantum system and the classical observer. It doesn't explain why a detector should count as sufficient, or whether a conscious mind is somehow necessary, or when precisely a possibility becomes an event. The theory predicts astonishingly well, but the explanation attached to it has always felt questionable. In 1957, Hugh Everett III proposed an answer that was radical precisely because it refused to add anything new. Instead of modifying the equations, he took them more seriously than anyone else wanted to. His suggestion was simple in form, but devastating in its implication. The wave function doesn't collapse. Ever. The equations of quantum mechanics already describe reality completely, and if those equations continue evolving into multiple outcomes, then perhaps the mistake is not in the mathematics. perhaps the mistake is in our refusal to believe that all of those outcomes are real and that they exist. This became known as the many worlds interpretation. Under this view, every possible result of a quantum event actually occurs. Reality doesn't narrow into one history, it branches out into many. The universe doesn't choose one path and erase the rest. It unfolds into a vast structure of parallel, non-interacting branches, each containing one outcome that appears singular from the inside. What looked like collapse was only a limitation of our understanding. If many worlds is true, then the reality you take for granted is not the structure itself. It's only your local position inside of it. Every quantum event becomes a fork, every unresolved possibility a divergence. There's a branch where the particle decays and a branch where it doesn't. A branch where the detector clicks and a branch where it remains silent. A branch where events unfold in the way that you remember and a branch where they don't. At the level of ordinary experience, these branches become isolated from one another through a process called decoherence, which is why the world still feels stable and classical from within. You don't meet your alternate selves in the hallway. You don't watch possibilities shimmer in front of you like overlapping transparencies. The branching isn't dramatic in the way that fiction imagines it. It's much, much more quiet than that, more mechanical and yet more absolute. And this is the point where the theory stops sounding abstract and starts becoming a lot more personal. Because once you accept that every outcome happens somewhere, a disturbing asymmetry emerges between the world as described from the outside and the world as experienced from the inside. And hidden inside that asymmetry is the seed of quantum immortality. To make the idea of quantum immortality easier to understand, philosophers and physicists created a thought experiment called quantum suicide. The setup is simple. Imagine a device connected to a quantum event with two possible outcomes. If the event resolves as option A, the device fires and takes you out instantly, you're gone. If it results as option B, congratulations, nothing happens, you have continuity. Each time the experiment runs, your fate is directly tied to a random quantum result. Under an ordinary single-world view of reality, this is just a deadly gamble, far worse than Russian roulette, with every roll of the dice giving you a 50-50 chance of proving your mortality. However, under the many worlds interpretation, the situation changes completely. The quantum event does not produce one final outcome that replaces all of the others. Instead, it causes reality to branch out into these different outcomes. In one branch, the device fires. Sorry, you're done. In another, it doesn't. Hooray. Both outcomes happen, but in different branches of the universe. From the outside, both branches are equally real. There are worlds in which the experiment ends with your death and worlds in which you survive to hear the click. But from your own point of view, you always survive, since you can only ever be conscious in the branches where you are still alive to experience anything at all. The branches in which you die are still very real, but because they contain no continuing awareness, there's no observer left behind to register the result. If every lethal quantum event creates at least one branch in which you survive, and if your consciousness can only ever continue along the branches where it remains conscious, then subjectively you would never experience the moment of your own death. From the outside, death still happens. In fact, it happens often. But from the inside, awareness seems to keep finding itself in the branch where the story hasn't ended yet. Other people still lose you. Bodies will still fall, tragedy strikes, but your own perspective appears to be dragged again and again into the improbable branch where the story continues. And this is what turns quantum immortality from a comforting idea about eternal life into something a lot darker. This is the first major distortion people miss when they hear the phrase. They imagine immortality as indefinite youth, or at least indefinite coherence. A body with a unified consciousness that goes on functioning forever. But the logic of the theory doesn't care about comfort, dignity, health, or even your own identity. It only cares, if that is frankly even the right word, that some strand of awareness remains available, just enough consciousness to preserve a point of view, an observer, just enough neural function for experience not to collapse entirely into nothing. And that threshold, as it turns out, may be horrifyingly low. You don't need to be whole as a person to count as continuous. You don't even need to be well physically or mentally. You may only need to still be there. And that's where the fantasy curdles. Because once survival is stripped of its wholeness, it stops looking like a gift and starts looking like an everlasting prison cell. This is why some philosophers describe the end point not as immortality, but as a kind of ghostliness. Not supernatural in the way that we often think of it, but probabilistic ghostliness. A condition in which your existence becomes mathematically marginal, suspended in the far outskirts of what should still be happening. If the body deteriorates, then consciousness may not continue as a clear, uninterrupted stream. It could fragment, it might stutter, it might even thin into discontinuous flashes. Brief windows of awareness opening inside longer fields of confusion, pain, sedation, amnesia, or neurological ruin. Perhaps what persists is not a stable self moving cleanly through time, but a sequence of degraded moments, each barely sufficient enough to count as a continued observation. Not a life, but intermittent residue. Not eternity in the grand mythic sense, but eternity reduced to broken frames. A mind that cannot fully die, but can no longer fully live either. If that sounds less like immortality and more like a hellish punishment, that is because the theory doesn't distinguish between the two. It only distinguishes between awareness and the absence of awareness. Everything else is just collateral. There is also the problem of isolation. And this may be the cruelest consequence of them all. Because even if your consciousness continues, everyone else still lives inside branches where you don't. Your family mourns you. Your friends miss you. The world recognizes your absence and then reorganizes itself without you. In the surviving branches, they may still be present for a while. But as time passes, ordinary mortality continues its work on them too. They age, they weaken, they disappear. The people you love don't become immortal just because your awareness keeps slipping forward into narrower possibilities. So the longer the process lasts, the more separated you become from the human world that once gave your survival meaning. And this here is the hidden reversal at the center of the whole idea. We fear death because we assume the opposite of death is life. But quantum immortality suggests the opposite of death may simply be more experience. And those are not the same thing as life. A theory that cannot distinguish vitality from persistence ends up exposing something we usually try not to think about. What we actually want is not an endlessly long life. It's a meaningful continuity of our present conscious experience. It's wholeness. It's a self that remains capable of living rather than merely existing. Once you strip that away and you clearly see that immortality is a punishment because it completely strips life of whatever meaning and beauty it holds. There's another problem buried inside quantum immortality, and it cuts deeper than the fear of an endless, damaged survival. Even if we grant the full logic of many worlds, even if we assume consciousness always continues along some surviving branch, it still doesn't mean that the thing continuing is meaningfully you. This is where the theory collides with a question older than quantum mechanics and more destabilizing than death itself. What exactly is the self that persists from one moment to the next? We talk as if identity was obvious, as if the person who wakes up tomorrow is simply the same person who fell asleep tonight. But that confidence rests on something surprisingly fragile. Memory, bodily continuity, psychological coherence, narrative stability, these are the threads from which the ordinary self is woven. And none of them are as absolute as they feel, at least not in any measurable way. In everyday life, we ignore that fragility because change happens slowly enough to preserve the illusion of a single, uninterrupted identity. You age, but gradually. You forget, but selectively. Your body renews itself cell by cell. Your beliefs shift and your values mutate, your memories distort, and still you continue referring to the result as the same person. The continuity feels real because the transitions are smooth. But identity may be less like a solid object and more like a pattern that keeps reasserting itself across time. And patterns can degrade and they can split. They can drift so far from their origin that the name remains while the structure underneath becomes almost unrecognizable. If that's already true in ordinary life, then quantum branching completely shatters that illusion that there ever was one stable you to survive in the first place. Under many worlds, every branching event creates multiple future versions of the observer. These versions share a common past up to the moment of divergence. But after that, they begin to accumulate different experiences, conditions, and outcomes. At first, the difference might be microscopic. In one branch, a particle decays. In another, it doesn't. But over time, these small divergences compound into radically distinct lives, different injuries, different environments, different memories, different endings. So the question is then, which one is you? All of them inherit your past. All of them can legitimately say they came from the same earlier observer, but they can't all be numerically identical in the ordinary sense, because they become distinct centers of experience. Identity, under branching, becomes distributive. The self doesn't continue as one line, it proliferates into many different descendants. That matters, because quantum immortality quietly relies on a trick of language. It says that you will always find yourself in the branch where you survive. But that sentence only feels intuitive because the word you is doing way too much work. Which you? The present observer imagining the future? The future branch that retains enough continuity to feel like a successor? The set of all descendants with some claim to your history? Once branching becomes real, identity no longer behaves like a single thread pulled intact through time. It behaves more like a tree. And a tree doesn't have one future, it has many. Some branches flourish, some terminate, some twist into distorted forms that still emerge from the same trunk but no longer resemble the shape that you expected. The theory doesn't guarantee your personal immortality. It may only guarantee that among your many descendants, some conscious remnant continues. That is a much colder statement, in my opinion. To see why, imagine a less dramatic version of the problem. Suppose tomorrow your brain were altered in a way that preserved some memories and some traits, but fundamentally changed your emotional life, your values, your perception, and your capacity for reflection. The resulting person might still answer to your name, they might still recognize your loved ones, and they might still carry fragments of your history. But would you regard that being as straightforwardly identical to yourself? Or would you feel that something more essential had been broken, even if the biology was still working? We already recognize in cases of severe brain injury or degenerative illness that there's a difference between an organism surviving and a self remaining intact. Oh, sure, the body continues, awareness continues, but continuity in the richer personal sense becomes uncertain. Quantum immortality tends to glide past that distinction. It treats any surviving awareness as sufficient. But a consciousness that merely emerges from your prior state is not necessarily the same as the person in that prior state. This is where the concept starts to resemble teletransportation thought experiments and other philosophical puzzles about personal identity. If a perfect copy of you were created elsewhere with all your memories up to this instant, would you wake up as that copy? Or would the copy simply believe it was you, while your own consciousness remained tied to the original body? There's no consensus on this, because the problem exposes a deeper instability in how we think about selfhood. We treat first-person continuity as a primitive fact, but under analysis it becomes difficult to locate. Is identity a matter of physical continuity, a psychological resemblance, causal connection, informational pattern, or, hey, is it something else entirely? Quantum immortality leans heavily on the idea that first-person continuity will always follow survival. But unless identity is far simpler than it appears, that assumption is doing much more philosophical work than the physics itself. And the darker possibility is that the theory only preserves a kind of successor bias. In every branching event, there will always be some future observer who remembers being you. That observer will naturally interpret their own existence as a continuation, because memory presents itself from the inside as inheritance. But memory isn't proof of identity. It's evidence of causal descent. A copy with your memories would also feel like a continuation from the inside. So would a damaged successor, assembled from enough surviving fragments of your former mind. The fact that some future awareness claims your past doesn't settle whether your present consciousness truly becomes that awareness. It only shows that a later observer carries your imprint. Quantum immortality, in that sense, may not protect the self. It may only guarantee the production of survivors who insist they are its rightful continuation. And I get it. That sounds abstract until you confront what it means emotionally. The fear hidden inside death is that the unique center from which experience is happening ends. The one reading these words, the one carrying this exact perspective, this exact structure of memory and feeling, this exact sense of I. If quantum immortality merely says that some future observer with enough resemblance continues in a surviving branch, then it hasn't necessarily defeated that fear. The singular center you care about may still disappear, replaced by successors who feel close enough to claim the inheritance without being strictly identical to the original. In that case, the promise of subjective immortality begins to thin out. What survives isn't necessarily the self after all, it may just be its aftermath. And yet, this doesn't fully dissolve the horror, it just changes it. Because the theory no longer threatens you with endless life as a stable person, it threatens you with indefinite fragmentation of your personhood. And that may be the most destabilizing implication yet. Because quantum immortality only sounds coherent if you already believe the self is a simple thing, a single bead carried forward on the wire of time. But the closer that you examine consciousness, memory, and branching identity, the more that image begins to fail. The self may not be a bead, it may only be a temporary knot, a local organization of matter and memory that holds for a while, then loosens, divides, and disappears into descendants that resemble it without preserving it perfectly. If that's true, then the real horror is that death may not arrive as a clean ending. It may be replaced by a long, splintering recession in which the self becomes less singular, less coherent, less certain of its own claim to be the thing that began the journey. Instead of one clean black screen, bang, you're done, you just live forever in an endless ocean of gray. Up to this point, quantum immortality has felt like a nightmare because it follows its own logic so cleanly. But this is also the point where the idea runs into its hardest resistance, from the structure of consciousness itself, from the biology of dying, and from the fact that the theory quietly assumes more than the physics ever actually gives it. Quantum immortality feels powerful because it borrows the authority of quantum mechanics. The problem is that it may be borrowing a bit too much. The first crack appears in the simplest place. The theory assumes that consciousness behaves like a single invisible thread, something that can continue smoothly from one branch of reality into another, so long as a surviving observer remains. But neuroscience doesn't describe the mind in that way. It doesn't reveal one unified witness sitting behind the eyes, waiting to be routed down the correct timeline. It reveals a distributed, fragile, highly physical process emerging from the coordinated activity of billions of neurons. You damage those neurons and the personality changes. Damage them differently and memory changes them. Damage them again and the continuity of self begins to fail. The mind doesn't look like a detachable essence from that point of view. It looks like a biological event. And if consciousness is inseparable from the physical substrate of the brain, then the language of jumping to a surviving branch stops making any sense biologically. This matters because the seductive version of quantum immortality depends on a categorical mistake. It takes the essence of another surviving brain in another branch and quietly treats that as a continuation of your present awareness. But those aren't the same claim. At most, many worlds gives you a duplication. It gives you parallel descendants emerging from a shared prior state. It does not, by itself, supply a mechanism by which first-person consciousness transfers from a dying brain here to a surviving brain there. That extra step is the entire horror and the entire premise of the idea. And it's precisely that step that the physics never proves. The deeper you follow this, the worse it gets for the theory. Because even if you ignore the substrate problem, even if you pretend consciousness is unified enough to be considered as a single stream, biology still refuses to cooperate. Quantum suicide thought experiments are clean because they rely on instantaneous, binary outcomes. The gun fires, or it doesn't. A clear dividing line appears between awareness and oblivion. But that's not how most real death happens, as I'm sure you're aware. Most deaths are a process of progressive failure. There's oxygen loss, then cellular damage, neural breakdown, inflammation, disorientation, sedation, delirium, coma, dead. Consciousness doesn't always vanish in a single clean cut. It often thins, fragments, and then decays. And once death becomes gradual, the whole machinery of quantum immortality begins to lose its grip. Because where, exactly in that slow biological collapse, is the branching supposed to save you? At what moment does subjective awareness decide, I'm not going to dim here, but I'm actually going to move over there? Does it happen when our memory is failing? When cortical activity becomes erratic? When identity is already breaking apart under chemical and structural damage? Well, the theory offers no answer, because the answer would require more than quantum mechanics. It would require a precise accounting of what consciousness is, where it begins, where it ends, and how much of it must remain for a future observer to count as a continuation of the present one. And science doesn't currently have that account. Quantum immortality behaves as though it does. It treats the most mysterious feature of existence, first-person awareness, as though it were an obvious rule. And if you haven't cottoned on to this yet, it isn't an obvious rule. It is the very thing that we don't understand. Then there's the problem of probability. The many worlds interpretation says that all possible outcomes occur across branching universes. But if everything happens, what exactly does it mean to say you are likely to experience one thing rather than another? In ordinary life, probability tells us how often outcomes occur. In many worlds, every outcome with non-zero amplitude occurs somewhere. So the theory of subjective certainty begins to rely on a very strange maneuver. It says that branches in which you die should be discarded from your first-person accounting because no conscious observer remains there to register the result. But critics argue that this is not licensed by the mathematics. There's no equation in quantum mechanics saying that awareness must automatically privilege the surviving branch while ignoring the dead ones. That conclusion feels intuitive only because death contains no witnesses. But the absence of evidence is not the evidence of absence. My dad loves that saying. That distinction is devastating, because once you remove the emotional pull of, I can only experience being alive, what remains is much thinner than people expect. Of course, you cannot observe your own non-existence. Nothing can. But that doesn't imply that the next surviving observer elsewhere in the branching structure is guaranteed to be you in the strict first-person sense that matters to us. As if it's not bad enough, there is also a final problem, and it's colder than the others because it doesn't attack the theory's logic. It attacks its status as science. A scientific idea must, at least in principle, be capable of being wrong. There must be some possible observation that would count against it. Quantum immortality slips away from that requirement from the outside. It's invisible. Other people just watch you die. From the inside, it's self-confirming. Any close call can be reinterpreted as evidence that your consciousness remained in a surviving branch. The theory cannot be cleanly verified because only the survivor can claim the evidence, and it can't be cleanly falsified because the dead do not report back their experience. If you have an alternate experience, please tell me, because I need to know. A system that turns every possible experience into apparent support is never science. And this is why most physicists reject the idea. And even many of those willing to entertain many worlds don't accept the subjective leap it demands. However, studying quantum immortality is still interesting because it reveals something in us. I'm sure you experienced it while watching this video. It's our desperation to imagine consciousness as something more durable than our flesh. Our instinct to treat the self as fundamental even when neuroscience can't prove it. Our refusal to accept that death may not be a puzzle with a hidden loophole, but simply a boundary built into the kind of beings we are. And yet the idea doesn't disappear when the criticisms arrive. It survives for the same reason all powerful ideas survive. Because even if the theory fails as a science, it forces us to ask what we mean by self, what we mean by survival, what kind of continuity would actually satisfy us, and whether consciousness is a thing that can be counted the way we count particles and branches and probabilities. The concept is probably too unstable to believe, but it's almost impossible to hear it honestly and remain unchanged. Because once you've followed it to the end, even if you reject it, one realization becomes difficult to shake. The fear of death was never just about ending. It was about not knowing what exactly is ending when the light goes dark. By the end of all of this, quantum immortality begins to look less like a theory of eternal life and more like an instrument designed to expose the limits of human thought. It starts with physics, then slips into metaphysics, then into personal identity, and then into the biology of consciousness, and by the time you arrive at the true end, the original promise has almost entirely dissolved. It does not tell us, with any real confidence, that we survive death by riding the surviving branches of the multiverse. What it does tell us, much more clearly, is that our ordinary concepts of the self, death, continuity, and observation are far less stable than they appear. quantum immortality is not powerful because it proves immortality. It is powerful because it weaponizes our uncertainty about what a person is. That's why the idea feels so hard to dismiss emotionally, even when it's weak scientifically. It attaches itself to something older than reason. The raw first-person fact that no matter how much you understand death in the abstract, you have never experienced your own absence. You have only ever experienced continuity. One moment leading into another, one conscious frame dissolving into the next. However rationally you accept mortality, experience itself keeps teaching the opposite lesson. You can imagine pain, you can imagine loss, you can imagine your funeral, your absence from other people's lives, your body decaying, your work unfinished, and your name fading. But all of that is still imagination happening from within our awareness. The one thing you cannot represent from the inside is the total disappearance of the representer, the end of the frame itself. And so the mind reaches for substitutions. Religion offers survival of the soul. Technology offers uploading the mind to some AI machinery. Legacy offers symbolic continuation, and quantum immortality offers branching persistence of consciousness. Different stories, all with the same end goal, trying to imagine a form of continuation because awareness cannot easily stare at a future in which it is not there to witness anything at all. But, if you ask me, I would say there's a hidden mercy in finitude. The old human dream was that death might not be final, but that finality might just be what gives life its meaning. Because endings do more than just stop things. They define things. A life is not meaningful merely because experiences happen within it. It's meaningful because it has boundaries, because choices exclude alternatives, because time runs one way. Love matters because people can be lost. Courage matters because risk is real. Urgency matters because there will not be endless chances to become who you want to be. Remove the reality of an ending, or even muddy it with endless branch-dependent continuation, and the structure of significance begins to distort. Life doesn't become infinitely precious. In fact, it's quite the opposite. And perhaps that is the final reversal. Quantum immortality begins as a rebellion against death, but it ends by making death look strangely necessary. Not desirable by any means, and not easy or fair, but necessary in the structural sense, as the horizon against which life becomes a whole rather than an indefinite residue. If you like the idea of the many worlds theory, you'd also like our video on how consciousness could exist in higher dimensions. Click the video on screen right now to keep watching. Ideas like this are powerful because they force you to think logically. You can't rely on instinct alone because that's exactly what breaks these kinds of thought experiments. But that's also why topics like this can feel so confusing. They demand a clear, structured method of thinking that most of us haven't really been taught properly. That's one of the reasons why I love Brilliant, the sponsor of today's episode. Brilliant helps you build that kind of logical and critical thinking through active problem solving. Instead of just watching someone explain an idea and then hoping that it sticks, you can actually work through these concepts step by step, which makes it that much easier to understand how they actually work and, more importantly, why they matter. It's a much more effective way to learn because you are constantly engaging with material rather than passively consuming it. Beyond these interactive lessons, Brilliant also personalizes your learning. It starts you at the right level based on what you already know, and then lets you progress at your own pace. It also encourages you to keep that progress going through fun and motivating challenges. I used to think that I wasn't a math person, but Brilliant completely changed that for me. It made me realize that most people aren't actually bad at math, they were just taught poorly. I've had countless aha moments that finally unlocked concepts that I've been struggling with for years, and that doesn't just apply to logic or math. Brilliant also covers computer science and even AI, breaking down complex ideas into something surprisingly intuitive. Brilliant also makes an amazing gift for younger siblings and relatives who are already glued to their phones anyway. It's designed for ages 10 to 110, so it's great for everyone. So instead of mindless scrolling, Brilliant gives them something challenging, interactive, and genuinely educational to do with their phones. To learn for free on Brilliant for a full 30 days, go to brilliant.org/aperture, scan the QR code on the screen, or click the link in the description. You also get 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant.